So in this video, we're going to learn how to calculate a dependent t-test. So remember, again, it depends on the kind of research design that you have. So we still have one IV, just two groups, but now we're testing the same subjects in both the groups, two different observations. So we have a within subject design. We're going to do a dependent t-test, and we'll see how that differs. So in this example, we're still doing test scores, but instead of two different classes, let's suppose that we have one class that was assessed at two different times, say like a midterm and a final. So it's the same class, same people in that class, but they were observed twice. Now we have observations from each person on two different occasions, right? So this is the same data as we used in our independent t-test example. Hopefully you can see, and I would in fact go back and compare it to those examples as we're going through this so you can see how things differ. That's the idea of using the same data here. But here's our data as they are. Now it's a little bit, the layout's a little bit different, you'll notice, and it's dependent on the formula. So what we need here with our dependent t-test, it has something different. It's this D thing. And the D is really a difference score. The difference between your first observation and your second observation. So here I've labeled it D, and you can see that we get this by taking the midterm score and subtracting the final score. Now it doesn't matter which one you call the first score or the second score, but you do want to be consistent, right, from your observations. You don't want to mix and match. So what we do is we do 50 minus 65, right, 75 minus 69, 80 minus 79, and so on to get this D. So we're going to need sum of D. So when you add up D, you're going to get 10, right? And we're going to divide the 10 by 5 eventually, right? It goes in here. We're also going to need the sum of D squared. So adding up all this squared. So 10 squared is 100, right? So that's where those values come from. They're going to go in the formula here in just a second. But we also need to square D first and then sum it up. So minus 15 squared is 225, 6 squared is 36, and so on. So these are D squared values. We sum them up, and you're going to get 474. Now, once you have these quantities, it's just a matter of substituting, plugging into the formula. So we have sum of D, that's 10, goes here. We have 5. Now, don't be confused here. We only have one N because you have to have pairs of scores. It's 5 pairs of scores. It's not like there's little N1, little N2, because if you don't collect data from one person on two different occasions, then you can't use that person's data only partially, right? It's paired scores. So N here is 5. That can be a little confusing. So sum of D squared goes into 474. Sum of D, remember, sum of D then squared was 100, and of course N was 5, and you just plug in 5 there. Okay, so now it's about solving for it. So remember, just go after these ratios. So you're going to do 10 divided by 5, 100 divided by 5. We'll subtract that out. Maybe take the square root of 5 there. And so you have 10 divided by 5, 100 divided by that. 5 minus 1 is 4. I left the square root of 5 alone. That's fine. Next, 474 minus 20. Then you're going to divide out these guys, right? Now remember, you can get a little confusing here. This is standard error of the mean, right? So what you're going to do is calculate your standard deviation first. That's what this top part of this part of your denominator here is. So go ahead and divide that out, right? And then go ahead and take the square root of both. That's what I've done in this last step. So what you're going to do here at the very end is this is the standard error of the mean. So you need to divide 10.65364 by 2.23607. That's really the only trick with the dependent t-test, is because it's standard error of the mean. Let's go back and look. So this is your standard deviation formula, right? So if you go back and compare this to standard deviation, this is standard deviation, and then you divide by the square root of n to get standard error of mean. That's what it is in the denominator. So that's the order of operations. That's the only trick. So we have 2 over 4.76. When you divide that out, you get this. So now what we have to do is get a critical t for the dependent t. So you're going to look at a different table for dependent t, and the degrees of freedom here is the number of pairs of scores. Again, n being 5. 5 minus 1 are 4. We have a critical t. We compare them, and our obtained t is less than our critical t, so we're going to accept the null. So that's how you do it. That's how you calculate a dependent t. In the next video, we're going to see how we can change power again and how it will affect the dependent t-test, just like we did with the independent t-test.